In this video, we are going to talk about how to construct a polynomial by backward differences method. And this is also called Gregory-Newton backward interpolation method. So we have a problem. A 3 points data is given to us and we have to construct the polynomial by backward differences method. And after we find the polynomial, we have to find the value of the function at given x, which is 6. So let's construct the polynomial by using the backward differences method. Since we have 3 points data given to us, so we know that if we have 3 points data x0, y0, x1, y1, x2, y2, and this data is equally spaced, we are going to use backward differences method and forward differences method only for equally spaced data. So if we have 3 points equally spaced data, and we have to construct the polynomial by backward differences method. So the first thing that we shall do is to name the last x as xn. So here last x is x2, so we are naming it as xn, and y2 will become yn. The previous values will be now xn minus 1, yn minus 1, and the value behind it would be xn minus 2, yn minus 2. So for 3 points data, the maximum degree of the polynomial is 2. So we will write P2 of x, Newton's polynomial, but for backward differences. So we have a0, no factor, a1, one linear factor, x minus, here instead of putting the first x, which was x0 for forward differences and divided differences, here we will put the last x, and we have denoted the last x, x2, as xn. So last x. We are writing P2, so we'll stop at a2 and two linear factors. One is the previous one, which is x minus xn, and one is the x behind xn, which is xn minus 1. So we have written the standard Newton's polynomial for backward differences. Now we are going to convert this polynomial in the backward differences operator form. What we shall do is we will convert a0, a1 and a2 in the backward differences operator form. So a0 in backward difference operator form was y and the last y. a1 was backward yn over h, and a2 was backward square yn over h square 2 factorial. Now let's plug these a's in P2 of x. So we have a0 yn plus a1, which is backward yn over h, x minus xn. a2 is backward square yn over h square 2 factorial, x minus xn, x minus xn minus 1. So we have written 2-degree polynomial. It's actually Newton's polynomial in divided difference operator form. So we have data here, x values 135 and y values minus 147. If we name this data, this is x0, x1 and x2. In the backward differences method, you call the last x as xn. So we are going to call x2 as xn. So see, when we have xn equal to x2, x is same as x and bases should be same. So it means that n should be same as 2. So what we shall do is, in this polynomial P2 of x, Newton's polynomial in divided difference operator form, in the places of n, we will put 2. So P2 of x, in the places of n, we put 2, y2, backward y2 over h, x minus x2 plus backward square y2 over h square 2 factorial, x minus x2 into x minus n is 2, 2 minus 1 is 1, so x1. Now in this polynomial we have to plug in the backward differences and the x values. So to find the backward differences, we will construct the backward difference table from the given data. So the x values and y values in the tabular form are 135 minus 147, 1, 3, 5, minus 1, 4, 7. Let's construct the table. So first we will calculate the differences. Arrow between these two terms, minus 1 and 4. So 4 minus minus 1 gives us 5. Arrow between 4 and 7. So 7 minus 4 gives us 3. Arrow between 3 and 5 gives us 3 minus 5, which is minus 2. So we have calculated the differences. We will just name it now. X0, X1, X2, Y0, Y1, Y2. The third column is named as backward YK and the fourth column is named as backward square YK. The first value in the third column is named as backward Y1. We have seen this in the definition and construction of backward difference table in the previous videos. Backward Y2 is 3, and in backward square YK column the value minus 2 has the notation backward square because the column name is backward square YK, so backward square, and it is actually Y2. So now that we have constructed a backward differences table, so we are going to pick these values from this table and construct in the polynomial P2 of x. So here we have P2 of x, which is also called f of x, which is also called y. So it is y2 backward y2 over h x minus x2 plus backward square y2 over h square 2 factorial x minus x2 into x minus x1. Know that backward differences method and forward differences method only work on equally spaced data, and we can see that our data here is equally spaced because the difference between every two consecutive values here is same. Here 3 minus 1 is 2, 5 minus 3, it is also 2, the difference between the x values. So we can see that h here is 2. Let's plug in the values from this backward difference table. We have y equal to f of x, which is equal to P2 of x. Y2 here is 7. Backward y2, in the backward yk column the last value is backward y2, so it is 3 divided by 8, which is 2. X minus x2 is last x, which is 5, plus backward square y2. Backward square y2 is in backward square yk column and it is minus 2. Minus 2 over h is 2, its square, 2 factorial, into x minus x2 is 5, x minus x1 is 3. Let's simplify this polynomial and we have y equal to f of x is equal to P2 of x degree 2 polynomial, which is 7 plus 3 by 2 x minus 5, and we have minus 1 over 4. Because 2 factorial is just 2, it cancels with 2 in numerator and we have minus 1 by 4 here, into x minus 5 into x minus 3. So we have constructed polynomial by using backward differences method, and we can verify that this polynomial is correct. In this polynomial, if in the place of x you plug x equal to 1, you should be getting y as minus 1. Let's see that if it is so. If in the place of x in this polynomial you plug 1, the value of x, you should be getting the value of y, which is minus 1 in the data. So let's see if we get y value as minus 1. 7 plus 3 by 2, 1 minus 5, minus 1 by 4, 1 minus 5 into 1 minus 3. So the y value that we are getting here is 7 minus 6 minus 1 by 4 minus 4 minus 2. 4 cancels with this 4. So you have 7 minus 6, 1 minus 2, and you get minus 1. So you can see that when in the place of x you plugged 1, you got y value as minus 1. The same way you can verify if in the place of x you plug 3, x3, you should be getting y as 4. The same way if you should plug 5, you should be getting y value as 7. So we have the polynomial constructed by using the backward differences method, which is 7 plus 3 by 2 x minus 5 minus 1 by 4 x minus 5 x minus 3. Let's look at the question. We had to construct the polynomial by using backward differences method. We have done that, and then we had to find the value of the function at x equal to 6. So to find the value of the function at 6, function is same here as the polynomial, which is same as the y. So put x equal to 6. Here we get f of 6. On the right hand side we have 7 plus 3 by 2, 6 minus 5 minus 1 by 4, 6 minus 5, 6 minus 3. We get 7 plus 3 by 2, 6 minus 5 is 1, minus 1 by 4, 6 minus 5 is 1, 6 minus 3 is 3, 3 into 1 is 3. So we have 7 plus 3 by 2 minus 3 by 4. Let's simplify and we get so the value of the function at x is equal to 6 is 19 by 4. So here we have constructed the polynomial by using the backward differences method, and then we have found the value of the function or the value of the polynomial at x equal to 6.